In this tutorial, we're going to show how the profile machining toolpath using the bevel-edged options can be used to form sharp external corners as well as sharp internal corners. Okay, let's close this file. So File, Close. I'm going to open the 3D beveled sine CRV file that's available from the samples folder. The sign opens in the two-dimensional view, and you'll see here that we've got some text that's based on a font with sharp external corners. The font also has sharp internal corners. For example, in the center of the A here, we've got sharp internal corners. On the underside of the A, we've got another sharp internal corner. On the outer edges of the fonts, we've got these sharp external corners. This sign is 36 inches long by 18 inches high, and we're cutting it out of 3/4 inch thick material. Let's swap from the drawing tab on the left to the toolpath tab on the right of the interface. I'm going to click and drag to select the font. As usual, just check the material settings. So we've got 3/4 inch thick material, retract height of 1/8 of an inch, and 1 inch at the end of cutting. That's all okay. So we're going to create a profiling toolpath. So 2D, so from the first line of icons, we have the 2D profile cutting toolpath. So we're going to machine around the outside of each letter, but we're going to do it using a V-bit. So we're going to select from the database. We're going to use quite a large 90-degree 1.25" diameter V-bit. You'll see here on the right hand side we've got the diameter of the cutter, the included angle, the pass depth. So if we're cutting tough material, we may wish to go down in multiple increments. We've also got step overs for finishing and roughing, and the spindle speed and cutting feed rates. Now these will have to change depending on the material that you're cutting and the CNC machine that you're running. Okay, so we'll select that cutter. We're going to cut the chamfer on the outer edge of each letter to a depth of 0.4 of an inch. We're going to machine around the outside, as I've just said. And if we specify from the options menu, if we click on corners, we're going to machine sharp external corners and also sharp internal corners. So for example, in the corner of the B there, we want the cutter to be lifted into the corner. An important thing to note here is that the software automatically calculates an allowance for us. This 0.4 of an inch allowance is based on the angle of the cutter and the depth that we're cutting at. If we're using a 90-degree cutter, the cut depth and this allowance will always be exactly the same. So if we change the cut depth to be 1/2 inch, the allowance distance would be 1/2 inch as well. If we were using a different angle cutter, say for example a 100-degree or a 110-degree V-bit to add the chamfer, then the depth and the offset would be different. But you'll see in a moment that we need to use this value, so it's worth making a note that the allowance offset needs to be 0.4 of an inch. Let's give this toolpath a meaningful name. So I'm going to call it chamfer and calculate. What this is going to do is calculate a toolpath for us. If we preview the results, you'll see that it's chamfering the edge of the lettering, and it's creating this sharp external corners and the sharp internal corners. If we edit this toolpath, go back to corners, if we switch off the sharp external corners and recalculate, reset the preview the toolpath again, you'll see now that we get this radiused edge around the chamfer on each of the letters. So on the letter A there, for example, we've got a radiused corner instead of it coming to a sharp 90-degree corner. So let's go double click to edit the toolpath, go back to corners, switch back on the sharp external corners and recalculate. You'll see now if we zoom in, the toolpath is being forced to a sharp corner. Reset the preview the toolpath. You'll see we've now got a very nice sharp external corner, but we've also formed very neat, sharp internal corners. Okay, so we've formed a bevel edge on the lettering there. Let's just tile the view. So if we say view, tile the windows horizontally, what we've got here in the three-dimensional view, if we look at the letter B, for example, the letter B represents the distance across the font here. So the distance across the width of the font is being maintained on the surface of the letter. The chamfer is being extended outside of the size of the letter. So we're chamfering to make the letter larger on the outer edge. Also on the inner edge, so on the inner edge of the letter B, the software is offsetting on the inside and on the outside. So it's retaining this flat portion to be the same size as is defined by the font, then it's adding the chamfer. Now if we go back and calculate another 2D toolpath, so I'm just going to select all of the vectors for the bar example here. We're going to say calculate another 2D profiling toolpath. This time we're going to cut all the way through the material, so 0.75 of an inch through. Select the cutter. This time we're going to use a 1/4 inch end mill. So 1/4 inch end mill to cut all the way through the material. And we're going to cut around the outside. And we want the cutter, again, we're going to use sharp external corners. But the very important thing here is if we cut using the 1/4 inch cutter onto the edge of the text or the font, then we're going to machine away the chamfer. So what we need to do is offset the toolpath outwards by the allowance that we looked at for the previous chamfering toolpath. For this cutter, it was the offset allowance needed to be 0.4 of an inch. So what that's going to do, it's going to offset the toolpath outwards and it will machine to the base of the chamfer, giving us the result that we want. So if we calculate this toolpath, you'll see there that the toolpath runs around the valley of the chamfered edge. If we preview that toolpath, you'll see now that we're left with the chamfer on the outer edge of the lettering. There is a problem with this toolpath in as much as once we'd cut the letters out, they would break free. So probably damaging the letters or maybe even damaging the cutter. So I'm going to go back and edit this toolpath, profile machine. Let's add some tabs. So we'll make the tabs 1/2 inch long, 1/8 of an inch thick, and we'll make them 3D tabs. Now you'll see here that we can say edit tabs. If I delete all of the tabs for a moment, I can very easily just click where we want them to be. So clicking adds the tab. Let's add some on the internal edges of the B as well. Let's put a tab there, a tab there. We do the same on the letter A. So we're literally just clicking to insert tabs, and the tabs are going to hold the letters in place to stop them breaking free. Very quick and easy to do. Okay, with the tabs in place, we can now close, recalculate this toolpath. If we reset the preview, what we've now got is, we zoom in here, you'll see on the bottom of the letter B, we've got this little 3D ramp, which is in effect going to give us a tab, leaving material holding the B in place. Double click to maximize this view. If we preview this toolpath, we view straight down the Z, you'll see there that we've got the little yellow tabs indicating that the letters are going to be held in place. Then preview the chamfer. That's going to give us the sharp external and the sharp internal edges on our lettering. Very quick and easy to do, and the key to it all was selecting the options for corners, sharp external and sharp internal corners with the chamfering tool. Once we're happy with the toolpaths, we can preview or estimate the machining times for the project. If we're happy with the machining times, we can then save the toolpath. So we'd save toolpath 1 would be the chamfer toolpath. select the post processor, save the toolpath to disk, select the second toolpath for profile for cutting out, save that file to disk, and then run them on the CNC machine. Thank you for watching the tutorial.